And quicksort is actually the new sorting algorithm that we are going to introduce in this lecture slide. Quicksort works like this. Works like this. So it has a certain pivot here, and it wants to divide all the smaller values here and all the large values here. So basic idea is that given a sequence here, given a sequence of the values, you are going to select one value which is going to be called pivot value. So pivot is going to be a threshold to divide the sequence into two subsequences. Then divide the sequence into two subsequences, and sequence with the less value and sequence with the greater value. So after having pivot here, this is going to be the whole new sequence, and this is going to be the whole new sequence. Before that, it was this range. So that's the here. What we are going to do is the recursion, and there are going to two function calls, recursive function calls here. And then after keep dividing by the pivot value, what you are going to return it is the subsequence sorted value plus pivot plus quicksort of the sorted sequence of the higher values. This example, we selected number 4 as our pivot. So what happens is that actually if you see this sequence, we put number 4 in the middle and put all the smaller values before this number 4 and all the higher values after this number 4. So we have 312 in the lower sequence and 589, 57 in the higher sequence like this. And after that, it just works like the recursion. We are going to select one pivot values, and then that pivot value again divide the sequence into two parts. For example, put 2 in the middle and 1 and 3. However, these are all one elements, so there is no further comparison can be done. So 1 to 3 is going to be just one output. 7, on the other hand, if we put it in the middle, it will divide into two parts, 5, 5 and 9, 8. And after that, we select 8 as our pivot and 8, 9, 5, 5. And these are all aggregated. How? 5, 5, 7, 8, 9 like this. And it will come to this point. And 1, 2, 3 is come to this point. And this pivot pool can come here. And it will create this whole sequence being sorted. Multi-sort is a kind of utilize a similar method which is dividing sequence into subpieces. However, the multi-sort always breaks it into the middle. So always it going to have the similar size of the subsequence. However, quicksort is based upon the pivot selection. If pivot value is selected in the kind of bad way, it means that one subsequence is very short and the other subsequence would be very long. So, for example, merges, in case of the merge sort, if we have this range, it always breaks it into middle. And then we have this range and we have this range, always break up in the middle. Like this. However, in terms of the quicksort, if we have this range and it's based upon the pivot selection. What if the pivot is being selected in a very bad way? In that case, if we write this, and it will have these subsequences, and write this, it will have these subsequences. This is the really bad case of the quicksort, right? So in terms of the multi-sort, it always breaks it in the middle. So that's about it. However, quicksort, the subsequence division is very dynamic. The size is dynamic. So we have to be careful about the pivot value selection. So this divides the sequence with the pivot selection. So actually this shows what if we have a really bad selection of the pivot. What if the pivot is really biased? Let's assume that pivot is always the smallest number. In a bad luck. In bad luck, we always get the smallest pivot numbers. Let's imagine that. Then what happens is it's just another selection sort happening. Let's imagine that here always smaller values, so 1 is being selected. Then all the other values, these are all greater than 1, so it's going to be one part of the sequence, and there is no other sequence here. And then from this sequence, we are going to select the smallest number as our pivot value. So 2 is being selected. And put 2 here, and there is no values smaller than 2 in this subsequence. So there is nothing that can go here. And all the other values are greater than 2, so it's going to be here. Happens here, happens here, happens here, like that. Then this is going to be O of n squared logic. So that is the result of a biased pivot. So hence, the pivot selection is very important. How to select pivot? One thing that we can do is the median. And other thing that we can do is the random. However, random, you can just pick any numbers, and that's the order of 1, constant time operation. Finding median actually involves the iterations. You have to do the order of n search. So actually this is the order of n. So median value will give a better subsequence fraction, subsequence division. However, it actually takes some time to find that pivot value. Actually, practically merge sort is more preferable because that you don't have to worry about the pivot selection. It always breaks up in the middle, and if it is a random sampling, the values are random sampling, then there is no kind of order. In that case, we can just break the sequence, divide the sequence in the middle, at the middle. So that's what you can do. So this is the implementation of the quick sort. So here, this is just a preparation phase, right? And here, this is the escape routine, right? And then here, actually, this is actual code, right? And here, the recursive call for the lesser value sequence. And here we add up the pivot value. And then this is another recursive call. That's for the greater value. So that's the random number generation. And then we select a pivot. Here we are going to just assume that always pick the first element. And then dividing the subsequence. and then what happens is the recursive calls here.